Okay, we're going to wrap up the last three problems from Chapter 2, Section 4B. Yesterday we covered A and B, and we get into a real-world problem here. And to be honest, the calculus portion of this is not really very challenging compared to some of what we've done. But now we're getting into a real-world environment. So anytime we can draw a picture, not a bad idea. An object is dropped from the top of a 100-meter tower. Its height above the ground after t seconds is given as, I'm going to write this as h of t, height at time t. And I'm actually going to make it negative 4.9 t squared plus 100, because that's typically how we look at quadratics. How fast is it falling 2 seconds after it's dropped? I'm going to draw a picture of this, and since time is only... if we were playing parabolic charades right now, I think we would all know we could come in and mimic this by looking like a parabola, but upside down, steeper. Now, how we would handle the 4.9, not exactly sure, but then we'd be up 100. Since time, we typically talk about 0 on, I'm just going to look at this graph like this. So I would... Up 100 is my vertex, coming out of there flat, and then coming down, like a parabola, where this would be 100. This, I don't know, I could solve for this value, set it equal to 0. Maybe we don't have to do that. But an object is dropped from the top of a 100 meter. This is meters. Its height above the ground after t seconds. This is seconds. Right? Now, really important to understand, because this used to mess with me. I would think, well, if we want how fast it's falling after 2 seconds, then I just put 2 in here. But when I put 2 in here, that gives me its height, right? I mean, I could put 2 in here in my head and go, well, that's 4 just about times negative 5, about negative 20. At 2, I'm up here to somewhere close. This is like 2 somewhere close to 80. But that's the height. That's not how fast. What would we talk about our speed here? Would we probably solve this and say miles per hour? Because that's a speed, right? What speed would we be working with here? Meters per second. That is the y's divided by the x's. The y's divided by x's is the slope, right? How much the y's change and how many meters, like if we drop 10 meters in 2 seconds, that gives us an idea of what our speed is. It's 5 meters per second. That's our average speed. Okay? So meters per second is our unit, but that is slope. What we're looking for is the slope at that instant, the slope of this tangent line. Is it clear? Meters per second. We want the slope of this curve. How do we find the slope of a curve if we can't cheat and just say, oh, it's negative 9.8 t? We go through the process. And soon you won't have to go through the whole process all the time, but we're going through the process. So I want the limit as h approaches 0 of something on h. And that can be my little rubber stamp. Now, please do not confuse this h with this. In fact, I'm going to call this capital H of t for height. It's not the same as this h. Remember what that h is? That's how far we go over between the 2 points. So I want f of t plus h. You can use x. You want to specialize in x? Use x. I'm going to go f of t plus h. But h is a factor that takes things, squares them. Multiplies them by negative 4.9, and then adds 100. Is that okay? That's f of t plus h. The next thing I'm going to write is minus parentheses. Do I have to write parentheses? Sometimes you don't. But it doesn't hurt. Way more likely to be hurt by not writing it than you are by writing it. So minus h of t. h of t is just negative 4.9 t squared plus 100. h of t plus h minus h of t. Okay, now, if you are more comfortable than doing what I'm going to do, you can FOIL this out, leave it in parentheses, and then distribute the negative 4.9. I'm going to do that in one step. When I FOIL this, pretty clear I get a t squared, right? Distribute the negative 4.9 to that. I'm going to get a negative 4.9 t squared. When I FOIL this, I'm going to get a t times h and another t times h, 2 t h's times negative 4.9. Is that okay? Again, you can FOIL it first, distribute. When I FOIL this, I'm going to get an h squared, distribute, minus 4.9 h squared, and plus 100. Distribute, that's why we put the parentheses there, so we don't forget that right there. I get plus 4.9 t squared. That sounds familiar. Oh yeah, I had a minus one of those. Yeah, there's no h. If there's no h there, I'm going to cancel it. I get a minus 100. That sounds familiar. I had a plus 100. Again, if you do that and you forget to put the parentheses, you're probably going to find your error right then when the 100 doesn't cancel and becomes 200. Ooh, that should have canceled. Right? Okay, all on h. So what good happens here? Minus 4.9 t squared cancels 4.9 t squared. Plus 100 cancels minus 100. These don't combine, but they both have h's. So this becomes limit as h approaches 0, divide top and bottom by h, and I get negative 9.8t minus 4.9h, and h's goal all along was to be 0. Put in 0, and I get negative 9.8t minus 4.9 times 0, or negative 9.8t. That is our slope formula. That is h prime of t. I want h prime of 2. I don't want this y value. I want the slope of the tangent line. Negative 9.8 times 2, negative 19.6. Negative 19.6 what? Meters per second. Now, what's the question asked? How fast is it falling? Is it falling at negative 19.6 or is it falling at 19.6? It's falling at 19.6 meters per second, isn't it? It's rising at negative, okay, so we would say falling at 19.6 meters per second. Is that okay? I'd probably feel pretty good about you getting to negative 19.6 meters per second. But when it says how fast is it falling, how's its height changing? It's changing at a rate of negative 19.6, but how fast is it going down at that instant? 19.6 meters per second. Is that all right? So calculus starts to become our friend. What is the rate of change? Rate of change. Well, here's a rate of change. Meters per second. Right? That's a slope, a rate of change. Y is divided by x. This is saying what's our slope? Rate of change is slope. Y equals 3x plus 2. Going up 3 over 1. It's changing 3 inches in 1 day. Rate of change. Of the area of a circle with respect to radius. When they say area with respect to radius, I'm saying area with respect to radius, A of r. Well, what is area of a circle with respect to radius? Pi r squared. I know that. And then this is saying, what is the slope? when r is 3. But what's its rate of change in size, inches per time unit, whatever, when r is 3? So I need slope. Do we know what the derivative of this thing is? Yeah, too bad. Limit as h approaches 0. I want a of r plus h. That's pi times r plus h squared. The next thing I'm going to write, minus parenthesis, plain old a of r, pi r squared. Oh, you told me I needed parentheses there. I didn't really need them. Sorry. All on h. You can plan ahead and not put them there, but I'm just going to go minus parenthesis every time I get there. Okay. Limit as h approaches 0. I'm going to get an r squared times pi. Pi r squared, that sounds familiar. Oh yeah, I got a minus 1 over there. How about that? They're going to cancel. I'm going to get 2 RH's when I FOIL. So I get 2 pi RH. 2 RH's, or 2 RH's with a pi multiplied in. And I'm going to get h squared with a pi multiplied on. Is that okay? That's just r squared plus 2rh plus h squared, distribute the pi, minus pi r squared, all on h. No h, better cancel. Pi r squared minus pi r squared, cancel, cancel. Can't combine, but can divide out h. The limit as h approaches 0 is, divide out the h, 2r pi. Oh, I'm going to go 2 pi r because that just has a good sound to it. 2 pi r, h is canceled, plus a single h pi. Therefore, I get a prime of r is, put 0 in, gone, 2 pi r. That ought to be a giant, the derivative of the area of a circle is the circumference of a circle. That ought to be, I wonder if there's really a correlation or if that's just happenstance. Okay, anyway, we are supposed to find the slope, when r is 3. So that is 2 pi times 3, or 6 pi. Now, that's how fast area is changing. If we're talking about 3 inches, the area is changing 6 pi just inches? Do we measure area in inches? Square inches, and that would be like per time unit. They never specified. Square inches per time unit. Okay. All right. This is a good one. At what point is the tangent to this horizontal? Well, holy smokes. This thing's just a parabola. When is the tangent line horizontal? At the vertex, right? How do we find, what's the easiest way to find the vertex from a quadratic equation? Not using quadratic formula, but from a quadratic equation. Anybody remember the shortcut? Uses A's, B's, and or C's. Anybody? We're going to use some of the 1, the 4, and the negative 1. No? That's all right. We'll come back to it. What do I know about horizontal lines if we decide this tangent is going to be horizontal? Every single horizontal line out there has one thing in common. What's that? Say it just a little louder. They're all y equals. Okay. What else about those? So slope is 0. Thank you. We're studying slope right now. Slope is 0. I'm going to find the slope for all of them. And then I'm going to set it equal to 0. Let's see what x value makes that true. So, surprise, surprise, limit as h approaches 0 of, there's a hint, f of x plus h. F is the factor that takes things, doesn't care what they are, puts it here and here. So I get x plus h squared plus 4 times x plus h minus 1. Just that is f of x plus h minus parentheses f of x. X squared plus 4x minus 1. Okay. FOIL. X squared. I think that'll cancel. Yeah, better. Plus 2xh. Will that cancel? Doesn't have to. Might. Plus h squared. Will that cancel? Doesn't have to. Plus 4x. Will that cancel? No h is better. Plus 4h. Might not cancel. Minus 1. Will that cancel? Yes. Better. Distribute the negative. Minus x squared. Minus 4x. Plus 1. So in that last quick step, I canceled the x squareds, I canceled the 4x's, and I canceled the minus 1. Everything else is on h. Limit as h approaches 0. Every term left, these 3 terms, reduced by h. 2x plus h plus 4. And h's whole goal all along has been to be 0. So f prime of x, or the derivative of, or the slope formula of, put 0 in, and I get 2x plus 0 plus 4, 2x plus 4. And that stinks because we knew that's what it was before we started. If you took honors pre-calculus last year, we knew that was going to be 2x plus 4, and you're not going to have to do that forever, but you're going to have to do that for a while. Go through that process. And we're going to be really, really good at that. That's going to be some of the first things you're faced with on the exam. Okay, so it's horizontal when this equals 0, not when x equals 0, when the slope equals 0. When the slope equals 0, x equals subtract 4, divide 2. Negative 2. So what is the point when we're horizontal? It is negative 2 something. Put in negative 2. Get out 4 plus negative 8. So minus 4, minus 1, minus 5. That's the point that it's, and that must be the vertex. All right, how about, let's just take a look at this thing, quadratic formula, for a second. Quadratic formula is the opposite of b plus or minus square root b. Just watch this, you don't have to write this down. B squared minus 4ac. We're going to try to make the connection here. All on 2a. We all know that. That is, could be written, it'd be weird, but it could be written this way. And what does that give us? That gives us the zeros of the function. Or if it was a parabola, y equals this, it gives us the x-intercepts. And if I know the 2 x-intercepts, mustn't the vertex be halfway between them? Well, if my two x-intercepts are here and a little bit right of there, and here and a little bit left of there, isn't here the middle? Start here, go to the right 7 steps. Start here, go to the left 7 steps. Well, if I start here, I must be at the middle. Does that make sense? That's how we find the x. Does that sound familiar? The x value of the vertex is negative b on 2a. It's negative b on 2a. So we could have just said, oh, negative 4 on 2 times 1, 2. Oh, it's at negative 2. Then we'd be done. This is a terrible way to solve this problem. Okay. Smarty pants. If you were in honors pre-calculus last year and I have f of x equals ax squared plus bx plus c, what is f prime of x without having to go through all that limit mess? Matt? 2ax plus b, right? 2ax plus b. Let's set that equal to 0. where the slope is 0. X equals subtract b, divide 2a. Huh. There's some connections, right? We went through the limit process and we just found that out. We went through this derivative process, just found that out, and we reasoned through there. And we were told years ago that, well, the x-axis, or the x point of the vertex, the x coordinate of the vertex is just negative b on 2a. All right? Okay. I'm not going to quiz 2-4 tomorrow. I might quiz 2-4 next Tuesday. You need to have 2.4 done. And I'm going to take questions here in just a moment. But you also should be getting into this test review and taking a look on that. On Friday, I suspect Fridays will go either through the 4th page, down here past 6th. I might even stop it after that 5th problem before there. I've got to just get a feel for what's a good time division on it. But there'll be a Friday, Monday portion of this test. So I won't go beyond 6 now. So that makes certain you're taking a look at that.